Okay, so adding and subtracting rationals. Again, with these rational functions, we need to think about how important the number 1 is. Like 2 divided by 2 is 1. We've got x plus 2 divided by x plus 2 also represents 1. X divided by x also. These all represent 1. So really, we're not changing what the expression is. What we're doing is we're just changing what it looks like. So if we think back, if we have a half of something and we're adding a fifth of something, we're going to have to change these fractions into common denominators, okay? So one way to do this is if I multiply this by 5 over 5, and then I multiply the right-hand side by 2 over 2, right, then we're going to get a common denominator. So the 1/2 changes to 5 divided by 10, plus, and the one on the right side is 2 divided by 10. So now what we have here are common denominators, and we have 5/10 plus 2/10 gives us a value of 7/10. Okay, so the same idea applies to expressions when we have variables in them. Okay, so here on this left-hand one, right, I've got x divided by 3 plus 6 divided by x. If I don't know here, what I'm going to do is multiply by x and then x. And over on the right-hand side, I'm going to multiply by 3 and then 3. So what happens here, x times x is x squared divided by 3x plus 3 times 6 is 18 divided by 3x. So you can see what we have here is a common denominator. So all we're going to do is just combine what's on the top. So just be careful with your combinations here, right? X squared plus 18, all divided by 3x. And that's as far as you can go. You can't simplify the numerator or the denominator even farther, okay? So again, try to find a common denominator. So you'll see they begin to get a little bit more complex. Now we have numbers and variables. One trick that you can do, rather than multiplying by 8 over here, can I turn this 2x into an 8x? And the question is, yeah, if I multiply both sides here by 4, or sorry, both the numerator and the denominator by 4 over 4, I can just leave the right-hand expression alone. So 9 times 4 is 36 divided by 8x. And now I don't have to worry about changing the right-hand expression because we still have a common denominator, 8x and then 8x. So 36 minus 5 is 31 divided by 8x. And that's as simple as it gets, okay? If we move on to something a little bit more challenging, now we have two different binomials, right? And here is where we're going to keep these binomials together, all right? So what is missing from the left-hand side? From the left-hand side, I know that I'm going to need an x minus 6 and then an x minus 6. And then I know I need on the right-hand side an x minus 7 and then an x minus 7. So you can see, again, we're not changing the expression, right? What we're doing is multiplying. Now here, we're going to do a couple of tricks here, but the first thing I wanted to show you is that, well, we're just going to distribute and then we're going to have to area model or FOIL over here. So if I look at the left one, I've got 7x squared minus 42x all divided by, now I'm going to keep this together, x minus 6 and then x minus 7. And then the right-hand expression, I'm going to keep the same denominator, x minus 6. Notice how I haven't factored it yet or FOILed it out yet. And now here, we're going to have to use the area model to kind of figure this out. So what I've got here is 7x and then plus 3. And then I've also got an x and then a minus 7. Okay, so I'm going to go ahead and figure that out. 7x squared minus 49x, okay, plus 3x minus 21. So if I can combine these, I'm going to get 7x squared negative 49 plus 3 is going to leave us with minus 46x. and then minus 21. Okay, so our last and final step here is to combine everything under one fraction, right? Because now I have a common denominator, x minus 6, x minus 7, and I'm going to combine. Okay, so the first thing I'm going to look at is the x squared plus the x squared. So I've got 14x squareds. And then I've got the x's. I've got negative 42 x's plus negative 46 x's is negative 88 x's. And then the last one is the only number that I have left is plus 21, so I'm going to do minus 21. Okay. Now this is completely simplified. Sometimes you can simplify a little farther here, right? But in this case, we're just going to leave that alone just as is. Okay. And then this last example right here, things to be aware of here is 6 minus x and x minus 6 are different. So if I factor out a negative 1 here, what's going to happen? The 6 is going to become minus 6, and the negative x is going to become plus 6. Okay, so really what we need to understand here is that in order for both of these to be the same, I've got a negative 1 x minus 6 on the left. Okay, and over here, I'm just missing a negative 1. Okay, so what we need to be aware of here is if I have two binomials, which are kind of like reversed of each other, make it look like this so they're similar, and then understand that I'm going to need a negative 1 over a negative 1. Okay, so now what we can get here is negative 1 times x minus 6. And then over on the right-hand side, we're going to get plus negative 1 x minus 6 over minus 3x. Okay, so our last and final step here would be x minus 3x is negative 2x divided by negative 1x minus 6. And you can see here that a negative divided by a negative becomes a positive. So our final simplified version of this would be positive 2x over x minus 6. And then we are done. Okay, hope this helps, and I will talk to you all in class or office hours.